Hello, everyone, and welcome to Ignite. Today, I'm going to be talking about activating Microsoft Fabric with real-time data for analytics and AI. My name is Alok Pareek, and I'm a technical founder and the head of products at Striim. And I'm really excited today to discuss how Striim continuously integrates data for AI and analytics workloads into Microsoft Fabric. My background is in database systems, as well as with database replication, high availability, data integration, and stream processing. You could reach me at alok@striim.com. So let's get started. In terms of the agenda, today I'm going to get us started with some quick trends in data warehousing and analytics to set some context for this session. And next, I'm going to talk about the result of these trends on enterprise architectural patterns, particularly as they relate to real-time data integration, with Fabric being an endpoint for the data integration. And I think that you'll get the most out of this session if you're somewhat familiar with some of the Fabric concepts, particularly with the data store offerings. So with that, let's get started. And yes, I will also be showcasing a product demo in the last 5 minutes. So we have about 20 minutes, so let's get started. So first, I want to touch on a few common challenges with traditional data warehousing systems. So we've all sort of seen the evolution of data warehousing systems with sort of their popularity with share nothing architectures for massive parallelism, etc. So what were the problems? Some of the challenges were around data volumes. These volumes started growing from terabytes to petabytes to exabytes, and also more and more increasingly we are seeing data being generated at a much more accelerated pace. And it is difficult then, as you provision, your data warehouses, to figure out how do you forecast the data growth and how do you accommodate for, the storage and the compute. So in effect, in these traditional systems, there was a tight coupling between the storage and the compute, and that made it a significant challenge when it came to just sheer data volumes and growth. The second part has to do with the fact that the kind of data or the variety of data that you're operating on is no longer just limited to structured data, where traditionally your reports would just take a look at largely relational structured data from your operational systems. Increasingly, we see a mixed workload, and that mixed workload tends to comprise of not just structured data, but also data that's coming in from your semi-structured sources or unstructured sources. It could be text data, video data, and coming in from really different types of logs or potentially over services, notifications through bot activity, etc. So traditional data warehouses, again, weren't necessarily meant to both store and analyze all kinds of data within one engine. The other challenge that often would plague some of the service level agreements in these classic data warehousing systems was just overall the lifecycle part of it. Oftentimes, if you wanted to add new compute to it, you'd have to take a downtime, and that would impact your SLA. And naturally, overall, then we saw a shift similar to other systems. For obvious elasticity and cost considerations, the shift to the cloud. Okay, so that sort of what brings us, to Microsoft Fabric. So Fabric aims to address these traditional warehousing challenges by offering a comprehensive analytics suite. And so all of the requirements from data warehousing and from data engineering and from data science, your BI workloads. The idea is that we want to have all of these addressed in an integrated ecosystem through a software as a service offering. And the idea is to, again, decouple the storage and the compute but at the same time offer a unified way to access all of your data, so that multiple workloads could take advantage of it. With that, it is a very powerful paradigm. It's a lake-centric storage approach, and all of the data for your analytics workloads, for your machine learning workloads, is being stored in an open 𝗬𝗲𝗸𝗀 format in Fabric. So with all of the elasticity and the interoperability and the serverless advantages that Fabric does offer, we still do have practical problems to deal with. And today I'm going to be pointing out two of those problems. The first one particularly is, over the last few decades, we have seen a number of different legacy applications, legacy systems, as well as the emerging best-of-breed applications and data products that are being deployed. So these are being deployed now on premise. They're being deployed on Azure. They're being deployed on non-Azure clouds as well. So how do you then bring together data from all of these silos into Fabric so that you can take advantage of the comprehensive offering that Fabric offers? So that's the first problem, which is the data fragmentation problem. And the fragmentation is not within necessarily different parts of just the one lake, but also it spans all of the data products, all of the applications that exist on premise and in the other clouds. Okay, and the second piece is the problem of data freshness, that typically as part of integrating data into either traditional data warehouses or now into Fabric, if that's being done through your traditional ETL sort of approaches, then it creates a very, very simple problem, which is that the data is not fresh. It's stale. It could typically be as of last night or maybe a few hours old, or potentially, in worst cases, maybe several days or weeks old. And that approach is a little bit outdated. So these are the two critical problems that I see need to be tackled still. And that's where Striim sort of comes in. So the first one is Striim to solve the problem of data fragmentation. It allows a continuous movement of data from multiple different disparate systems into Fabric, and the integration can be done via writes into Lakehouse tables, or it could also be done into warehouse tables or into files in the Lakehouse. As far as the batch problem is concerned, there are ways in which you don't have to go in and extract all of the data that is required based on just your traditional high watermark type of schemes, where you have potentially unique identifiers that help you identify the incremental delta change, and that's where particularly Striim has an offering to be very efficient and non-intrusive in terms of technology called chain data capture, which allows you to get data, particularly from enterprises, in a very, very non-impactful manner, and still keep up with the very large volumes that are being asked to be moved across the data pipeline. So last year at Ignite, we were very excited where Striim was selected as a strategic data partner, and for FY24 we are Fabric's data partner, particularly when it comes to delivering continuous workloads into Fabric with very low latency for their analytics and the AI workloads. And I'll take a couple of minutes to just walk through the functionality, and then we'll get into some of the common streaming patterns as well as the product demo. So if you take a look at how Striim fits into the ecosystem with Fabric, moving from left to right, there's a lot of out-of-the-box connectors Striim offers, which allow you to continuously grab data from your relational systems, from your NoSQL systems, from messaging systems such as Kafka and JMS-based systems or IBM MQ, as well as from file systems and storage systems, from applications such as Salesforce. And you can move a lot of this data, which typically is generated on the operational side. So, for example, you can see in this slide that it could be coming in from just a simple sale where there's order data, which, and also going forth and from a supplier's perspective, it could be inventory data and product data, etc. Then there's like shipping involved. There's a customer experience involved. It could be patient care and healthcare, that type of a system. So these are all operational systems. So the idea is that you could collect the data, with very low latency in an ongoing fashion. Now, once the data is collected using an out-of-the-box adapter, which you just have to drag and drop in a very simplified manner without writing any code, you are able to now massage and manipulate that data using the second part of Striim's offering, which is the stream processing capability. So with that, you're able to achieve inline transformations. You could effectively have concepts represented like tumbling windows and sliding windows or hybrid windows, which allow you to operate on that data, on an event-by-event basis, or on a windowed basis, where you could accumulate a set of data. So the reason you want to do that is you may want to take a look at some of the data that might be identified as personally identifiable data, and you want to mask that data, or potentially you want to encrypt portions of the data, or subset that data, or filter that data. So all of those capabilities can be done within the pipeline. Now, this sounds dangerously close to what traditional sort of task-oriented multi-flow pipelines would do, except that remember, this is being done with very low latency and continuously and in a real-time manner. The other powerful capabilities are also to be able to interoperate with external systems. And one of the more powerful ways in which you can augment and enrich the data is for prompt engineering for your AI workloads, where there may be specific attributes within the data that help you construct a better prompt. And so you could actually transform that event, create the prompt, and then invoke an external service, and that could, for example, be with OpenAI, and you could generate a completion, and you could actually go ahead and augment the same event with the completion if you wanted to. The other advantage for AI-oriented workloads is being able to take a lot of the textual data that might be coming in from some of these data sources and convert them into vector embeddings for very compact, efficient similarity searches down the line. So all of that capability is in this blue box. So this is prior to delivery into Microsoft Fabric. Okay, so this is sort of the end-to-end picture here, and then I'll get into some of the details as well. So when it comes to Fabric, there are three specific patterns that I wanted to comment on today. So the first one, you can see, again, going back to the prior picture, there's a number of different data sources, and you want to deliver this data, into Microsoft Fabric. So the way we would do that is through continuous change data capture. And as the event comes in, you could potentially, as I mentioned, do event enrichment with OpenAI for prompt engineering, and also build vector embeddings to further store the actual embeddings into downstream systems. And then with very low latency, we can deliver the data via a SQL endpoint into Fabric warehouse data stores. Okay, and the idea is that this is being done on an ongoing basis. So it's not just for data that actually is existing, it's also for data that's changing. So for example, if you do have DML activity in terms of inserts and updates and deletes, then we are picking those up and we are augmenting that and we are pushing that onto the warehouse table, and we're invoking, the actual capability to finally give a data set in Delta Parquet format that is queryable through your Power BI queries, which can then consume, the most recent data. So the end-to-end picture here is, somebody potentially can, do an update in the real world on an operational side, and within a few seconds or, a few minutes, depending on how you want to consume it, that data is available for your analytics to be available within Fabric. So that's the very, very unique capability that Striim has to ensure that your Power BI real-time queries, as well as any other machine learning workloads that are also operating on the warehouse tables, take advantage of the most recent image of the data that's coming in. So that's pattern one. And the second one is oftentimes the data that's coming in, potentially that may be residing in queuing systems or on other storage systems, and you want to go through more of a storage interface. So that's where we could also go in and deliver this into the Lakehouse, and then you can actually access that through the Lakehouse tables. So those are, again, interesting for your data scientists, for ML workloads, and also for the Fabric Copilot set of applications. Okay, so those are the two patterns that are very relevant here within this context. The next one is also gaining popularity as something called reverse ETL, and the idea here is that once data gets delivered into Fabric, you want to massage that using potentially your Spark jobs or additional workloads, maybe SQL workloads, etc. And you want to now move that back into the operational system so that you can actually make the system of engagement very action-oriented. And so this is where a lot of the Gen AI applications that are trying to combine multiple different systems, and potentially when we think of a mesh architecture, it may be grabbing data from an operational system as well as bringing data from an analytic system. What is going on here is because Fabric sort of has this unified view, then once you actually run your analytic workloads there, you condense some of the facts and move them back into the operational application, and that's what gives you a very powerful customer 360 experience, or also a very powerful operational efficiency based on the fact that you have the analyzed information available at the point of engagement. So that's pattern number 3. Okay. So how do you provision this? As far as Striim is concerned, you can actually go into Azure and in the marketplace, and you can go ahead and subscribe to the Striim managed service. I'm going to show you an example of that. So that's the first path, which is at the top. And the second one is directly to the Fabric interface itself. And so that's something that's my first forward-looking statement today. So that's something that is coming up. So today in the demo, I'm going to show you the first path. So this is how the overall integration works. So what we're going to try and do today is talk about a retail business where we are taking a look at a lot of the stores. And we want to see real-time insights, consumer pricing index insights for dynamic pricing. And that's the demo that we're going to talk about today. And what this shows is data that's moving in, in real time from your sales application, where there's a number of different tables. And we're going to go ahead and move the data into Fabric and then update a few things and then see that, in fact, your dashboards get refreshed in real time. Okay, so with that, let's go ahead and take a look at the demo. So like I mentioned, that this is a retail business with a chain of stores. I'm going to first go ahead and subscribe to the Striim Cloud Enterprise offering that's available in the Azure Marketplace. And within a simple few clicks, I'm able to provision the service, and I can sign in and start creating my first data pipeline. So there it is. So you can see that there are new adapters that are available for Microsoft Data Microsoft Fabric Data Warehouse and Lakehouse. So let's step into each one of them. So if I drag and drop just the Fabric data warehousing icon, it opens up a property template, and this is where a lot of the magic happens in terms of us, taking the data that's incoming and using a SQL endpoint to go ahead and interface with the warehousing tables. And there's a lot of different configuration policies that are possible there. Similarly, there's also Fabric Lakehouse, and so this is more of the storage interface. And you can actually literally create the files in multiple formats, including JSON and Parquet and DSV, Avro, XML, etc. Right, so those are the two ways in which you can seamlessly integrate into Fabric. So now let's actually go ahead and take a look at our Fabric tables, and you can see that there's no data currently in these tables. They're just empty. There are three tables here: the feature table, sales table, now on the Oracle side, I'm going to load up some data into my features table. And once I import data, I'm going to take you to the pipeline and see that the data is in fact being captured continuously. So that's the loaded data on in this case, on the Oracle side. And now you can see that I've received my first event in the pipeline. And already I'm getting close to 3,000 messages per second. And also I'm beginning to output messages in this case. And as we go ahead, we're going to log back into Fabric. And we're going to make sure that, there. So now all the data is outputted. So I'm going to come back to Fabric. And you can take a look at all of the three tables: store table, sales table, feature table, and you can see that all of my data is in fact loaded. Okay, so this was sort of the end-to-end pipeline that loaded the data. And next, I'm going to go ahead and go into Fabric, and I'm going to take a look at my Power BI and build a couple of dashboards that are going to give me visualization of the CPI insights and the traffic per store. So there are the dashboards that I'm able to build. And you can see that I can drill down into one of the specific stores, which is store 45. And you can take a look at its value. And remember the value because we're going to go ahead and update that. So now if I go ahead and update that value, this is a simple update on the Oracle side now. And once we update that, it's going to come in, and I'm going to wait for it to catch up. So now you can see that it added new events on the input side. I'll wait till the output side also catches up to that. And there you go. And now the data should be available within Fabric. And now if I go back to my dashboard and take a look at the value, I see an updated value there. There you go. And you can see that the value, in fact, was updated from the prior time that we saw the previous image of that. So this is sort of like an end-to-end experience of how you can enable and activate your Fabric offerings with real-time data using Striim from a number of different external systems, where the data may be coming in from on-premise systems. It could be coming from across clouds. So that was sort of like a very quick overview of our integration capabilities with Microsoft Fabric. Just to summarize, Striim is Microsoft's strategic data partner in delivering real-time enterprise workloads into OneLake in Delta Parquet format. And this is a significant benefit to the data engineering teams, the data analytics teams, and the data science teams for building next generation of real-time Power BI applications, as well as Gen AI applications, which are being fed with continuous real-time data in Microsoft Fabric. So thank you, and I hope you enjoy Ignite, and really appreciated your time today. For more information, you can visit go2.striim.com/trial-azure, and you can take this for a spin. Thank you very much for your time today.